So in this video I'll explain how to interface an IR sensor with a microcontroller using interrupt method. So we are going to use Atmega 16 microcontroller. So in the Atmega 16 we have three interrupt pins, three external interrupt pins, INT0, INT1 and INT2. So we are going to use the INT0 interrupt to connect IR sensor with the microcontroller. So we have this IR sensor module, and the output pin of the sensor module is connected to one of these interrupt pins. Now rest of the two pins, so rest of the pins are ground and VCC. Okay. So this is a hardware connection. Now in the programming side, now let's listen how to write program. First we have to enable the interrupt process. So it's a two-step process, first at the global level and then we have to enable an interrupt at local level. So this is done by calling SCI function, and we have to include the interrupt.h file, and at the local level we have different registers corresponding to corresponding to hardware interrupts, so external hardware interrupts. So we have to enable the INT0, and then we have to select a logic the signal level for INT0 to trigger the INT0. So the sensor provides a logic 1 when the object is detected. So we can select a positive edge triggered signal for INT0. Okay. Now this is the initial part, and in the main, so this is the int main, and first we have to call basic configuration function. So let's say your function is interrupt init, so you have to call this function. So this function contains the syntax to enable the interrupt at global level and local level, and to select the signal level. And this is the while one, and then we have to write ISR. These things we have to write an ISR corresponding to the interrupt INT0. So the ISR contains program or code for the task that you want to perform when the INTR, or when the interrupt is executed, or when the object is detected by the IR sensor. So this could be a syntax to stop the motor or take a left turn or right turn based on the requirement. Okay. Now one more advantage of using interrupt is that we can put CPU in the sleep mode. So we can write instruction to put CPU in the sleep mode. Okay. So this is not possible in the polling approach. So we can save power, or we can do power optimization by incorporating the sleep mode, because when the object is not present, the program the CPU will be in the sleep mode, and when the interrupt is triggered, it will wake up from the sleep mode.